All righty, let's talk about some real basic OBD2 diagnostics and some scanner fault codes to understand. This is for those that are just new to it, want to get a little bit more in depth, kind of head down that road to where some of us veterans are and understand exactly what's taking place in that vehicle when we're talking about OBD2 connector. Now, OBD1 went until 1995. In 1996, we had OBD2, which was onboard diagnostics generation 2. Honestly, being through that whole time was the best thing that ever happened to our industry because OBD1 was a nightmare to work on. It was really tough to do diagnostics and to see the data that we see today. So let's go on and take a look at a few things. When we talk about OBD2, we of course have a connector. And we've got to have some codes. And in those codes, we've got to have them broken down and explained of what they are and what they do. Today, there's so many ECUs and PCMs and all sorts of stuff on a car. Last I heard 18, 20, 22. I can't keep up with it anymore. And I don't even try. But the basic line of that is that when you hook up a scan tool, the right scan tool, this isn't your $29 one you get off Amazon or AutoZone. You've got to have something that they can pull and take you past pulling a code. Just because you can pull a code doesn't mean you can fix a car. You need to understand what that code is. You need to understand the divisions of that code. So let's take a look at that. So when we hook into that data connector, here's a layout that we see. We've got 16 pins. We have everything from manufacturer specific to a bus positive. We got chassis grounds, we got signal grounds, we got transmission signals. We've got a bus negative and a bunch of other manufacturer specific. So it pays to know which ones are which. Now, there's times I've gone in with a DVOM to check a circuit to see if the ground is there. Is the power there? You go and hook up your code reader or your scan tool and you don't have anything coming up, you're going to have to break out a DVOM because you want to know, do I have power? Do I have ground? Nothing happens without either one of those. So typical, we know what they look like, or if you don't, they'll look like this. They're generally going to be on the driver's side, hopefully underneath the steering wheel, sometimes behind the cover. Some of the later models had them behind the center dash, which is kind of a pain to get to. Even some of the older ones, we had to connect on the right-hand side, left of the passenger side in the front too. So find the connector, get it connected, boot up the scan tool, and take a look at it. From there, what you need to understand is that your processor, your ECU, is exactly that. It is a component that takes inputs and creates output signals. That's all it's doing. So once you understand that, we have grounds, we have power, we have inputs, and we have outputs. Helps you kind of understand, hopefully, a little bit better about what's taking place. So when we look at inputs, an oxygen sensor, it's an input. It's a tattletale to the whole vehicle system on the emissions, telling what the oxygen content is inside the tailpipe. We have a throttle position sensor, tells us where the throttle's at. We have a mass airflow sensor, says how much air is coming through. So those are kind of some of the things that you look at. On our outputs or actuators, you're going to have on the old styles, you'll have an idle air control valve, which is this bad boy right here. You'll have an EGR unit, you'll have an injector, and of course, then you'll have your ignition coils as well. So those are an output. So when you have, for instance, a input of mass airflow coming in, and you've got all of a sudden you push on the throttle, and the ECU sees this onslaught of air coming in, what's the first thing it needs to do? Well, first off, it better give it some more gas because we got air coming in and we got gas that needs to be delivered because we're looking for that 14.7 to 1 stoichiometric, which is 14.1 parts of air to 1 part of fuel. At least that was pre-GDI. GDI has changed that, but that's what we were looking at back in those days and on those type of systems. So from there, let's look a little bit about the actual OBD2 fault code, and let's break that down for you. So when we look at, and we have our code reader scan tool hooked up, a trouble code subsystem. If we have a B, that's going to be body. If we have a C, we're going to look chassis. A P is powertrain, and a U is network communications. Most of them are going to be right here in your powertrain. So then our next number in line is a type of code. Is it a standard code or is it a manufacturer code? Now, when it hits a manufacturer of a 1, things change. They change dramatically. So the standardization, pretty simple. Go through, okay, we got a P and a 0. So then we go to our affected subsystem. So number 1 is going to be our secondary air injector. Fuel is good. Number 2 is going to be our fuel system. Number 3 is ignition. So right here, we know we got an ignition code issue. From there, 4, if it was a 4, would be an exhaust monitoring system, or 5, an idle speed control or cruise control. 6, input output signal from ECU. 7 and 8 could be the transmission. Then we go to the last 2 numbers, which are very critical because those last 2 numbers indicate on this one that the misfire is detected in cylinder 2. That could be a 1, 2, 3, 4, 5, 6, 8, 10, whatever it is. It could be a 10, so we know it's in cylinder number 10. So hope that helps right there, breaking down that code so you have a little better understanding of what's taking place. From there, this is just a start. We're going to have some additional training courses, but the whole idea here is to help you understand what's taking place, to get a better idea of what's happening in your vehicles when you're hooking up a scan tool, to understand exactly what you're looking at. There's a lot more to be learned. Just because you can pull a code doesn't mean you can fix a car. Thanks for watching and have a great day.